Hello everyone. I'm recording this session to provide an introduction into the class project and what are the steps you need to follow when you do your project. So the project should be released tomorrow, and it's basically 50% of the grade of your grade. So please pay attention to all the details. Make sure you do it right so you can get the full grade for that. And it's really straightforward, nothing complex about it. You have done excellent so far in this class, so nothing to worry about. Here are the steps. So you have till December 17 to submit your final project. So it's going to be available tomorrow, so you have almost 6 weeks, more than 6 weeks. It's plenty of time. In my opinion, it might take you probably less than a week to finish it. On average, like yeah, less than a week. And I also uploaded the original project, which is the IoT sensor for traffic surveillance I talked about during the sessions. The first thing you need to do is to download this project, and basically it's full package. Everything will be included in that folder. Design files, like printouts, bill of material, everything actually. So you can open this project, go to Altium Designer and start by opening the project in Altium Designer. Navigate to the project folder, and of course you need to open this project here. So you will see it's hierarchical design, as we learned in I think session 10 and 11. And this is what you need to do for your project. It has to be hierarchical design. And the first thing you look into it, you see that it has a custom template for the schematic. As you can see, I changed the template, I created the template, and we'll talk about this in a minute. And each one of those is subsystem for modularity. So if you click on this module, it will take you, I just hold control down and left click in the mouse while I'm holding control. It will take me to the sheet. And as you can see, the schematic design is very descriptive, which is very important. You need to have this design readable by other engineers. It's not only you. So it also has to be modular, where you can reuse it in a different design. So here you can see, you can also click on it in here. Of course, you will see all different sheets for the schematic, and then you have the layout. If you click on the layout in here, it will load in a sec. It's loading. Yep. So it's a start from the 3D view. As you can see, flip upside down. This is the bottom side, and this is the top side. So it's very small sensor. It's not complex. It's easy for you, I think, to make it. And those 4 holes on the corners, these are just mechanical holes for mounting the PCB inside an enclosure. It's not a big deal. If we switch to the 2D mode and go into the layers, you can see we have only 4 layers. So let's show that in a single layer mode. What we can do in here, if you do Shift S, it will switch into single layer mode. Now you select the layer you want to show in here. So this is the top layer. As we can see, the layer underneath it, it's called GND plane, and from the name you know that this is the ground layer. And as you can see, there are stitching vias all over whenever is needed. Then the next adjacent layer is power. This is power plane, and everything in here actually is power. So this is VDD, this is VGPS, this is rail for the GPS, and this is for the SD card or the serial flash, and this is for the battery. And those are maybe other signals. It's not only power, so we have other signals. And on the bottom layer, as you can see, we have copper pour for ground. This copper pour here is the ground, and we have some traces. Now these keep out areas. These are important to stay in keep out mode, because if you look at what we have in here, we have two wireless module. This guy in here is basically a GPS, and this guy in here is Bluetooth and Zigbee module, and the area in here is an antenna. Same thing for this area in here, this is an antenna. You need to check the data sheet and the application note for this module, where they will ask or highly recommend to keep this area isolated from any cover or any components on the top and the bottom side. That's why you see here there is no cover, and same case for this area underneath the antenna, because if you put copper, basically you are going to attenuate the electromagnetic field around this antenna area, and that will degrade the reach distance for this wireless module, and you really don't want to do that at all. So you need to check the data sheet for that. So this is a quick overview about the project. It's very compact, as you can see. If we look at the size for this module, let me see, you can go into report, measure distance, click on the origin point, you go all the way to the other corner. So here we are talking about almost 4.6 centimeter by 3 centimeters. So it's very small. It's really small module. If you see it in real, check my dissertation or check the papers I published. It's very small, tiny module, and we need it to be like that because it has to be portable and mobile. So let's go back to what needs to be done. So this is just a reference for you. What you need to do is to redo this design. Basically, you start, if we go in here, so you can read about it in here first of all. Then you need to create your custom schematic. I need you to create your own template in here. Put whatever logo, whatever variables in here you are creating, and do it. You need to do it custom. Don't count on the standard template. A standard template is basically, if we do new schematic, this is the standard template. You see this table in here. You need to change this and put a custom template. It doesn't have to be this one, like this one. You can create your own with your name, with your information, and whatever you need to add to it. It can be also simple. I just need to see that you have updated the template, and in order to do that, you can see the reference in this video in here, how to update a template. And basically you need to find the original files in your system, basically where this template is located, and you need to open the original file and try to edit that. And to do so, you need to understand or figure out where the files are locally stored. If you go to the preferences in Altium Designer, under system, go to default location in here, and you see the document path. Under the document path, if you go to the document path in here, you will see Altium. Basically this is the same path. You browse into that. Inside the folder you will see templates. If you open that template, so the schematic sheets, it's SCH dot. Look here, this is SCH doc, DOC, but this is DOT. DOT is document template, DOC is just a document. So you just pull up this here and you will see the original file. And if you come to any of these parameters, as you can see, you can edit the whole table. You can even delete the table. So this is editable file. You can edit this file. Once you are done, save it in a different name, whatever name you want. And then when you need to change it, to change this one, you go into the design, sheet template, local, and load from file. And even if you save the file in the same folder, you should see it in here, listed in here. And you can load it and basically use that template for your own project. So this is in a nutshell how to change the template, but please review the video in here, and also I think we talked about it in one of the sessions as well. So you need to create the design, schematic design, following the design in the schematic print PDF. So if you open this PDF file, which is printed from the design files I just shared in here as a PDF. So basically you need to mimic this, mimic the schematic design. You can add your touch into it, it's not big deal. I even prefer that if you have your own modifications to it, that it's okay. Feel free to do it by all means, no problem at all. So basically take this schematic. Oh, this is the old schematic actually. So use the schematic in the design files in here and try to create the same hierarchy here, same sheets, and then in each sheet in your design you need to try to implement the same thing. Do not copy from here and paste into your schematic sheet. You have to place these components in your schematic sheet from the library I am providing to you, and you will see it in a minute. If you copy these, I will know from the unique ID of each component. I know these were copied from file to file or from project to project, and that is considered cheating. So you will get the 0 for this right away. So you should place those components on your schematic sheet one by one, do the connection and do the coloring. You see how the coloring is nice in here? The nice thing about the coloring, when you add the coloring in the schematic, that will reflect in the layout, and you will have a kind of color code for your traces in the layout. So this is what you need to do. It's basically recreate the schematic, and next you don't have to create any libraries. Here is the integrated library. Just download this library and add it to Altium Designer. You can add it to Altium Designer, like you can download the library here. Let's see. You can add it by just click on it and click install library, and that's it. Now you go into components, under components you should see the new libraries, and you'll see the components you need from the library. Or if anything is missing in here, you already have the project. You go into the layout, go into the design, and click make integrated library. And what this will do, if you don't have a library, or you have a project but you don't have the library, components library, you can extract the component libraries from the design files, and once you do that, it will take a couple minutes to compile that. And then here you go, under libraries, you will see that component libraries and new library is created, and this should be also added into your files here. And you also can click on it here. If you double click on it, it will basically try to extract and install. So all the components should be in this library as well. Okay, so this is the second step. I'm trying to walk you through the steps in here. Then the 3D model is attached for your reference. You can see the 3D model in a PDF file, and we already saw the 3D model in the design file. It's the same as in here. When you click on number 3 and you see the 3D model, this is the same thing. You don't have to worry about this, I would believe. Okay, preview. So the next one, you will need to check the bill of material. Check the bill of material. This will list all the components used in the design. The schematic design should include a cover sheet, which is a parent, and a child, which is a hierarchical design. As we said, we have one parent and we have all these childs sheets underneath it. And this is very well I think described in session 10 and session 11. You need to finish session 10 and 11 before you start working on your project. So you need to keep the GND and power rails global. Do not port them. What I mean by this, check out this reference in here. But what I mean by this, if you look, for instance, if you go into the power here, So let's say I think they are already global, so you don't have to worry about this point. I will update that in the description. So they are already global. This is revision B, this is not revision A. So they are global, you don't have to worry about it. You need to number the schematic sheet and annotate schematic after you finish placing the component, and you already know how to number schematic sheet and annotate them, basically just for repeat. You go in annotation, you do annotate schematic, and for sheet number schematic sheets, you sort them in the way you want here, and then click on auto sheet number, auto document number, update sheet count, which will update this, and you click OK, and everything you see here, it will show you sheet, how many sheets, and which the sheet number as well. So you need to validate the project and make sure to solve any error. So validation, right click on it, you click on validate, make sure, check out the messages, make sure there are no errors. Errors are not accepted. Warnings, sometimes they are accepted. So if any component is missing, you can use a similar component, and this is the case for caps or resistor, and most of them in the design they are 0402 surface mount resistor, small surface mount resistor. Once you are done with the schematic, of course, you need to go to design and update PCB document to port all the components in here. Then you need to create an outline for the board. You create just a board, and I specified in here you need to create layer stack of 8 layers. Right now we have 4 layers. And making your life easier, you need to create 8 layers stack up. 4 layers, 4 signal layers, and 4 power planes. So you can use 4 for signaling, and you need to use the other 4 as power planes. What I mean by that, 2 of them will be used for ground, and the other 2 will be used for power rails. And what I mean by power in here, if we go into the power, so we have VDD, this is the power supply, and we have the battery in here, as we can see. And if we go, we have VAN here, you can see that. And how you can know that, if you go into the design in here, you go into the power, and you look at the power traces in here, you can see the battery, you can see the GBS, power supply for the GBS, you can see the input, and also you can see those power rails for the serial flash memories. And basically the powers, it's the connection that power up the electronic component. Once you see VCC or VDD, this is the power input or the power pin for the integrated circuit. You have a ground, and you have also the positive power. If we take a look at different sensors, for instance, we have a VDD, those are power, and we have a ground. This is the power supply. So we need to have plane in here and a plane for this one. So this is the power plane. So the question is, what kind of layer stack up we need to do? As discussed in the sessions, always when you create layer stack up, you need to consult your PCB manufacturer about what stack they can make, what makes sense in the first place. So let's take for instance PCB Way, and you can design for that. And if you go into PCB Way here in this link, or you search in Google PCB Way layer stack up construction, it will take you to this link. Or you can basically go into this and go into what we need is 8 layers. So 4, 6, this is the 8th layer. You need to do 1.6 millimeter thickness, which is this, and I want you to do the 1.6 millimeter 1 ounce cover on each one of those layers. So this is what you can see. You have a cover on the top, then you have pre-preg, then you have a core which cover on both sides, pre-preg, PP, which is the pre-preg, then you have a core which cover on both sides, pre-preg, then core, then pre-preg. This is what you need to create. This is the layer stack up I need to see, and what you need to start before making placing the component or routing your layout. You need to create this layer stack up. This is what is required. I'm trying to make your life easier in this case. So What is the order? So if we look at the order, let's take this for instance in here. So if it's up to me to do this design, what I would like to see, basically I would use this layer 1 as a signal. Let's call it S1, and I would use layer 8 also as a signal, and I would call it S2. Okay, then I would use L2 as ground. Same case, I would use L7 as a ground. Why is that? If I have a high-speed signal running on the top layer in here, I need to have a reference plane right underneath it with minimum thickness, which is a pre-brick. So this layer will improve my EMI performance as well as signal integrity, and will reduce any electromagnetic field or electrical field happening on the top or the bottom layer. Okay, then what I would do, I would use layer 3 again as a signal. Let's call this S3, and layer 6 as a signal. Now I'm taking benefit of layer 2 and layer 7 to be ground, and this ground is basically used as a reference plane for S2, S6 as well as S1, S3. So S1 and S3 are sandwiched between a ground layer. Same case for S2 and S6, they are sandwiched with a ground plane in between. This is very good design in my opinion. Then what I would like to do, I would use I would use this layer as power plane, and I would use the other layer as ground as well. Why do I need power and ground adjacent to each other? Because I need to reduce, first of all, I need them to be strongly coupled together AC wise, and reduce the impedance on the power rails. So this will help my design to be more robust and provide the minimum impedance in the power rails. So if it's up to me, this is how I would organize the structure. If I can get my design to be routed with 4 layers, I can use the other 4s for power rails, ground and power as well. If you have a different suggestion, yes, you can do a different design or different structure for the stack up, but you need to justify the reason for any design you come up with. Okay, now let's go back into the steps. So you need to create this 6 layer, then you need to define the boundaries for the sensor. The size should not exceed 60 by 60 millimeter. Right now it's 30 by 45, so I'm allowing you to make it bigger, and I'm giving you 4 more layers to create this design. But if you make it smaller, is better. Try to make it smaller, but make sure you are not exceeding 6 centimeter by 6 centimeter. Now, point C, it's preferred that you find the best component placement by yourself. You can go and try to place the component in your design the same way I did in here, but this is minimum effort from you. This is the minimum effort I'm expecting from you to do, but I really would like to see that you have a different placement. You come up with a different placement, and you place the component in a reasonable way. And again, as we discussed in the session, the way you place the components depends on 2 factors. The first one, the function of the component. Like those modules, I need to have them close to the edge because I need to clear this edge under the antenna from any copper. Okay, the switch has to be on the edge, the connectors has to be on the edge, and then any other functions, they can be anywhere if they are not connectors. The other reason for placement, or the other limiting when I place component, is to make it easy to route. So you need to place them in a way you don't have so many intersection between the traces, and you could draw them easily without using so many vias to transfer between layers. Okay, so you need to keep those 2 points in mind when you do the design. Now this is not applicable. You forget about D. This is revision A, and I gave you the design for revision B. Really, this is revision B. It's not revision A. So this was for revision A and for the previous year class. So wireless module, GPS module, and micro SD card shall all be placed on the same layer. We don't have micro SD card socket. Don't worry about it. It's basically we replace the micro SD card with those serial flash memories. So don't worry about it. But GPS module and wireless module, they have to be on the same layer, which is the top layer. This is the top layer. And for all signal, via should have 0.25 millimeter hole and 0.5 millimeter diameter. So you need to make sure that your all the vias, they are consistent, and these are the size of the via. How you can do that, you can go into preferences in here, and you can fix this in your system if you want, and you can do into via. Well, let's not fix it in here. You can, once you place a via, you can do it, and then you can do it in the design rule, because I'm going to change the via size for the power rails, I believe, later. Yeah, here. So power and ground via shall have or should have 0.3 millimeter hole and 0.6 millimeter diameter. So it's a slightly bigger because it's for power. And you will need to create the custom via rules as I mentioned. Minimum trace width should be, minimum is 6 mil. You should not use smaller than 6 mil. 8 mil is preferred. All power pads, including G and D, should fan out using vias to the ground plane or to the second layer dedicated for the power rail. This is covered in session 11. That's why I told you, or session 12, sorry, session 12. You need to fan out these. You cannot like route the power rails or ground on the top layer because you need to reduce the impedance. Let me explain this, what I mean by this. Let's see here. Let's take for instance this cap. Here we have a capacitor. Let me show. It's already okay. Shift S. Okay. So you see this capacitor in here? This capacitor, it's fanned out. This is the VDD. You can see it's fanned out directly via into the power plane underneath it, which is the yellow one. And the ground here is fan out from the bed with a trace right to the via, and is fanning out to the ground plane, as you can see. This is what I mean by fan out. This connection has to be as short as possible to reduce the self-inductance, or what it's called parasitic inductance, from the cab into the power plane. And that is very well detailed in session 12. You need to see session 12. It's very important to read it and get prepared for the quiz. So this is what is meant by this. Then try to use 14 mil traces for fanning out the power pads. So those traces you are fanning out from the power pad into the via, make sure to use 14 mil traces like this, just for the power, because they are bigger. So the vias will be bigger, the traces a bit wider. You can use 8 mil, 6 to 8 mil for any signal, and use 14 mil for the power. Now create port outline on a mechanical layer of your choice. You know how to create port outline. It's very important. You can use keep out layer as well. It's no problem. You need to run the DRC check after you finish the layout. Of course, you need to lay out the board. Make sure everything looks perfect. And you don't have to round the corners, but if you want to round the corners, you can round the corners, as you can see here. If you want to keep them sharp, 90-degree angle, that is fine. Once you are done, you need to go tools, design rule check, and run the design rule check. Make sure there are no errors whatsoever. Okay. Once you are done, you need to create an active bill of material. And to create an active bill of material, I think we already have one here. You go to the project, add a new. You add active bill of material. Create, add new to the project. Oh, it will not show in here because we already have one in here. But if you don't have an active bill of material, let me open it. I can delete it, or I can create a project to show you. You will see it on the list. So this is the active bill of material, and this basically will connect directly to the supply chain. But let's delete this. Of course, we already have one, but just for representation, let's remove from the project. Okay, now if you right click on it, you will see that option, active BOM. Once you add it, okay, here you get the BOM material. You click on refresh, and that will show you the components, description, of course, and this will update in a minute. Then you can go into any component. If you only have one solution, you can add create manufacture solution. You click on the component. Altium Designer will take the part number listed in here, will show you that part number, and this component already exists in the Concord Brew library. You can click on OK, and this supply chain will be updated in here. You can see all those vendors or component supplier, they have this component in here. It's basically the exact component. So you can select which one is preferred number one. Usually I go with DigiKey number one, then Mauser would be number two as my choice. If you click on the part number in here, that will take you into the supplier website. Here you can see the component, you can see how many in stock and what is the price, and then you can order the quantity you want, and also you can see the description. So you do that for every single component, and you finish the bill of material. If this is done, click on the stars here as a preferred, and you see the green mark in here. It's ready. Once you are done, you need to save this file, your bill of material file. I'm gonna save it on the same file because I don't want to lose the old one. Then the next step, so I tried to put all the steps here in details. Okay. So create an output job file. You know how to create an output job file because you need to create the 3D model, generate active bill of material, the manufacturing file, which is the Gerber files, and the NC drill file. You need to create print out for the schematic and layout prints as well. You can see these for your reference. Pick and place machine file, assembly files. You can see the assembly drawing in here. Let's open the assembly drawing. Okay, so this is the assembly drawing. You see the component on the top side with the designators, and the components on the bottom side with also the designators in here. So if we go back to Altium Designer, this project has already an output job file under generated. Here, settings, output job file. So you can use this project as a reference for you. Make sure you are not going to copy or paste anything. So you see here a PDF 3D PDF. You need to select the container, which is PDF file, schematic print. If I select this, and this will print schematic. If I select PCB print, if I click on here, I click generate content. Give it some time. So here you'll see. Let me move it to this monitor. So this is printed out. This is the top. This is the bottom. This is the first inner. This is This is top, first inner layer, second inner layer, and this is the bottom layer. And this is a good way to verify your design, in fact. So here, remember, I have only 4 layers. In your case, you have 8 layers. So you need to go to configure, and this is the case for the other files you need to generate. And you go, so PCB print, you go into configure, yes, and pages in here. You see you only have top, you have GND, you have bottom. You need to edit the layer or add pages depending on the layer you want, and you can read about it in the help, how you can add it and stuff like that. Okay, so you need to add it for the other 4 new layers as well. Same case for other files in here. You can use the original design file as a reference to start with. Okay, so the next step is you need to generate the board stack report, which is also generated from the output job file. And then you need to create a draftsman fabrication and assembly drawing. See this link about the draftsman, and if we go into Altium Designer in here, let me see, I don't have draftsman. Let's create one very quick. Add a new draftsman document in here. It will take some time. Okay, so that it's local. I need assembly drawing, or let's go with default fabrication drawing, because I need to add the whole table and the stack up on it. It's loading. It's going to retrieve the data. Okay, let me close this one. Okay, so here you can see the stack up. This is the stack up. As you can see, this is a drill drawing. I would like to make it bigger for the drill drawing, and this can be moved in here. And this is the drawing table. This will list all the size of the holes and the number of holes. So I have 251 hole with 0.25 millimeter, and I have 93 with 0.2 millimeter, and so on. Okay, this is the stack up, and this is basically the top side layout. So what I can do, I can place and then additional views and try to play with these. These are very nice option to see what you can do or what you can add to the draftsman, which is called artwork. Usually they call it artwork. Then you can save this file into your folder, and you create, this is the fab, you create another one for assembly the same way we did, and that's it. It's just straightforward. And then when you are done with this, so this is your folder, the first thing you need to delete is the history folder. This history folder is going to be huge, it's gigabytes, because every 5 minutes Altium Designer will try to save your latest changes into this history folder, so please don't send it. So once you delete this folder, you can zip all these files in here, add them into a zip folder, add, and then please name it with your name. Just put your name in here and upload it into Canvas in here for review. So I did detail all the steps in here, but everything is straightforward, nothing is complex. Any questions related to the project, please put them into the group discussion related to the course project. There are extra credit for any questions and any answers, both for questions and answer, posted into the group discussion related to the project. And I will try also to answer those questions if no one answered them, but I will try to answer them in less than 24 hours. Okay, let me know if you have any questions.